So the problem we were looking at was it was corner competition. So if you remember corner competition from the second year, you should be okay with it. So it's things you've seen before, but just done a little bit more rigorously and maybe slightly more generally. Did you see it with only two firms when you saw it previously? And it was linear demand, I guess. Yeah. Okay, so it's a straightforward generalisation to n firms, really. So did you ever go at this?
I got stuck on the top one, but I managed to do the second one.
Okay. I hope there's not another typo or something. So where did you get stuck?
Well, I managed to do it for perfect competition, but I couldn't quite get the 1 over n rule.
Okay. Well, why don't you do the perfect competition thing first? It's not too difficult.
That's just a general cost function, isn't it? Not
What?
that. Yeah, that's
So
a general cost.
total cost.
Yeah, total cost.
Tom, what were the subscripts? So CI subscript 0. What does that mean?
Oh, okay. So this is the cost function of firm I as a function of the quantity produced by firm I.
Okay, but on the CI there's a comma 0.
Yeah. So CI0 is like the intercept. So that's like the fixed cost for firm I. CI1 is for marginal cost for firm I. Does that make sense? Yeah, maybe I should have explained the notation. Yeah, so the cost functions you saw before under monopoly was just C of Q was C0 plus C1 times Q, and C0 was like a total cost and C1 was like a marginal cost. But now everything's just indexed by I because potentially different firms have different costs.
Shouldn't be squared term, should it?
You don't need to differentiate anything.
No, you don't. You're right. You just set it equal. That's right. So you set price equal to cost, don't you? Price equal to marginal cost. So it's P equals. Don't you? I thought price equaled marginal cost. So you don't say.
Why is not Q squared?
It shouldn't be Q squared because we're
You
not
multiply
doing
out.
duopoly. Right? If
Um,
we're
you-
doing
you-
perfect
you-
competition.
You're multiplying out the brackets.
Yeah,
That was
which
why
is
you
wrong.
went- That's
Yeah.
why you.
That's why I put a Q squared, but obviously we're not doing the duopoly case, we're doing perfect competition case. So that, for deriving the perfect competition formula, is wrong.
Yeah, well, so one way you can derive perfect competition is to do what you're doing. I won't confuse you with something else. So under perfect competition, everything's efficient. The price gets driven down to marginal cost. So what he's done is he's set price equal to marginal cost. Okay, so price price as a function of quantity with some missing brackets here. Okay, that makes more sense. It's not P times Q, it's price as a function of quantity is the derivative of the total cost function, okay, which for firm I is CI1. Okay, so
So here back here.
It's equal to perfect competition, but obviously we need the 1 plus 1 over n, which is where I get this stuck.
yeah, okay, so is there any difference between the formula here and the formula on the board? There's a tiny difference
Sorry, what?
between this formula for perfect competition and the formula you derived there.
I suppose.
The other one's a marginal cost, and the other one's, can I see that? It's just total cost, isn't it? Oh, is that the same thing?
That's
No, never
that's
mind.
yeah. The notation's a bit confusing, isn't it? I should have made that a capital C and then things a little clearer. So that's this is no. You spotted the right thing. Okay, so there's no I subscript on the slide, and the reason there's no I script on the slide is because perfect competition doesn't really make sense when firms have different marginal costs. Okay, you know, firms have different marginal costs, and you've got perfect competition. The ones with high marginal costs just leave the market. Okay, so under perfect competition, you know, think of perfect competition as Bertrand competition when everything works properly with Bertrand competition. Okay, so under perfect competition, everyone with high marginal costs leaves the market. Okay, so you're only left with the guys who have the lowest marginal cost. So this is valid. You know, this formula is valid if everyone has the same marginal cost. Okay.
Would that be the sort of question that would come up on anyone's exams? Like, you'd have to explain yourself, basically.
Yeah, you could have to explain what. We haven't spoken too much about perfect competition, really, because perfect competition is this ideal that doesn't really exist. But you know, you might have a setup like this and solve it under Bertrand and solve it under Corno, and then you know, under Bertrand competition, you have all these issues where you have different marginal costs. Okay. So this was the easy case anyway, the perfect competition case. Good. And now to go to the other case, it's very similar to what we did for Monopoly, really. Just going to change that little C to a big C to make things clearer. Makes the notation different, doesn't it? Okay, so now let's do the Corno case. Okay, so the first thing we do with Corno competition is we write down profits. And what's happened to my pen? Stupid. So here's price. Here's the total cost function for firm I. Let's make that a big C. Okay, so the profits for firm I, so pi of I, is going to be, you know, it's what it always is, quantity times price minus total cost. Okay, so, and this is, I shouldn't do a big Q, this is the quantity produced by firm I, which we're denoting by little q. Okay, everyone's going to have the same price. Okay, the quantities might be different, but they all, you know, the market clears, so they all have the same price, and they potentially have different total costs. Okay, so we've got this demand curve up here, so we can substitute that in. So here we have Qi times demand, which is P0 minus P1 times big Q. Okay, and remember the big Q is just the sum of all the little q's. Okay, that's total quantity. The little q is the quantity produced by thermi. Okay, so this is Q1 plus Q2 plus quantity times price minus total cost function, which is this thing up here, Ci0 minus minus makes a plus. Oh, it was a plus originally. Minus Ci1 times big Q. Okay, and big Q again is with sum Q1 plus Q2.
Sorry, this is not a duopoly, is it? Like it's not a duopoly, is it?
It's n firms.
Okay.
It's oligopoly.
Okay.
What have I done wrong?
Why?
Oh no, I'm just saying because it's not Q1 plus Q2 with the closed bracket, it goes on to Q1.
Yeah, it goes on to Qn. What?
Okay.
Why is it a big Q for the individual cost function of a firm? Is that surely doesn't make sense?
Yeah, it doesn't make sense. Yeah. The typos will be removed from the slides, I think, but because no one ever does for problems, and I haven't run these classes in previous years, the typos in the problems still seem to be here. So yeah, you're right, that should be a little QI. Okay. Well spotted. Sorry about this. When I fix typos, they get fixed on the website as well. So I know it's annoying for you if you have typo, but it's quite hard to remove them all. Okay, so that was some good economic intuition, right? The quantity that matters for firm I is, in terms of its cost, is its own quantity. If another firm is producing a lot, that's not going to change my cost of production. Okay, my cost of production is just a function of how much I produce. So that was a stupid typo. I'm sorry. Okay, so we've got profits written down. Okay, the only thing that looks a bit strange here is that you've got this sum from 1 to n. Okay, otherwise it all looks fine, doesn't it? So we're going to differentiate profits to find where they're maximized. Okay, so this is differentiating pi I, profits of firm I, with respect to the quantity produced by firm I. We don't care about the quantity produced by other firms. We assume they're producing their optimal quantity, okay? So, easiest way to do it is using the product rule. So we have, this thing times this thing in brackets, okay? So it's the derivative of this thing, which is just 1, times the thing in brackets, okay? So the thing in brackets is just P0 minus P1 big Q. And then we've got the derivative of this thing, the thing in brackets, times Qi. Okay, so we've got plus Qi times the derivative of this, okay, which is going to be minus P1. Okay, we know that Qi occurs once in this sum. Okay, only one of these terms is Qi. So the derivative of this sum with respect to Qi is just 1. Does that make sense? And then we just have the derivative of this bit over here. Total cost just disappears. Fixed cost disappears. Marginal cost is all you're left with, so minus Ci1 Qi. Okay, so you can rewrite this if you like. So we've got a plus and a minus. Let's just make our life simpler and change that into a minus.
Does the QI go at the end when you differentiate?
Yes. It's not my data then, is it?
Sorry, can I be annoying and ask how you got the P0 minus P1 and the big Q?
So what we were doing was we were applying the product rule to this expression, okay? So we had the derivative of Qi, which was just 1, times this thing in brackets. Okay, so that's P0 minus P1 times this thing. This thing is just Q.
Um,
Okay, that's just defined as Q.
but are you not meant to differentiate with respect to? Oh no, I see what you did.
Yeah, so we differentiated that bit, and then we kept that bit. And then we kept that bit, which is why we've got a QI there, and then we differentiated this bit, which is why we get the minus P1. Okay. Yeah, you happy now?
Yeah.
Yeah, good, good. Okay, so the trick for doing Corno, it's always the same trick, it doesn't matter what the setup is. You always take the individual first order conditions and add them up across all of the n firms. Okay, so that's all you have to do here. So, this holds for firm 1, it holds for firm 2, it holds for firm 3. Okay, so you can add up across all of the n firms. So the sum of n copies of naught is just naught. Okay, it's easy. If we sum this across firm I is 1 to n, we just get n copies of it, because there's no I in this expression, right? Okay, so we get n times P0 minus P1Q. Okay, what do we get if we sum this term across the I firms?
Same thing as the times by n.
So what happens to QI as little qi as you sum up?
True.
Big Q. Yeah, exactly. Yeah, so the sum of the little QI's is big Q. Let's see. Okay, so this becomes minus big Q times P. Minus big Q times P1. Okay? And then this last term, can you express the sum of this last term in terms of average marginal cost? So what we have, right, is the sum from I is 1 to n of CI1.
You divide it by n.
Yeah, so if you divide it by, if you had 1 over n, that would be the definition of average marginal cost, right? That's what you're saying. Okay, so we know that 1 over n times the sum is average marginal cost, which we're just calling C1 bar. Okay, so we know this is true. So if we times both sides by n, okay, we have the sum of these CI's is average marginal cost times n. Okay, so we just have minus C1 bar times n. And in fact, the next step, it makes sense to do. Once you've added up, it makes sense to divide by n. Okay, that makes your life easier. Okay, so if we divide this expression by n, that n just disappears. We still get that. We get QP1 divided by n. Okay, minus average marginal cost. Okay, now you've just gotta solve for big Q. Let me clear some space at the top of the board. Okay, so where does big Q appear? Well, it appears here, and it appears here. So here we've got a minus P1 in front of it. Here we've got a minus P1 over n in front of it. Okay, so let's take big Q over to the other side. So we get big Q times P1, which is that P1, plus P1 over n, which is this P1 over n. And then on the right hand side we leave everything else. Okay, so we've got P0 minus C1 bar. Okay, let's rewrite this left hand side as big Q times P1 times 1 plus 1 over n. Okay, all we've done is we've got a P1 there, we've got a P1 there, we can take it outside of the brackets. Okay, so that's P1 times 1 plus 1 over n. Okay, so then we just divide through by this bit here. Okay, so dividing by that, we get Q is P0 minus C1 bar over P1 times 1 plus 1 over N, which I really hope is what I have on the board. Yes. Yeah. Okay. So, so this formula makes sense, right? If the price demanded when quantity, if the price that people are prepared to pay when quantity supplied is 0, so the price people are prepared to pay to get at least some of the good isn't bigger than marginal cost, average marginal cost, then nothing's supplied at all. Okay, so demand has to be high enough for the market to operate. People have to be prepared to pay more than average marginal cost. So that's where the top bit comes from. And on the bottom we have, we've got P1 on the bottom, just like we had with perfect competition. Okay, so so for the same reason. But we also have this new term, 1 plus 1 over n. Okay, so when n is 1, we've got the monopoly case. Okay, so you get 1 plus 1 over 1, which is just 2. Okay, so when n is 1, this is P0 minus C1 bar over 2 times P1, which is what we found when we had looked at the monopoly problem, right? Okay, so with monopoly, quantity is half what it is with perfect competition, okay, with these linear costs. But as n increases, okay, this bit gets bigger, okay, so this bit gets smaller, 1 over n. So as n goes to infinity, 1 over n goes to 0, okay, so this term just goes to 1. And then you get the perfect competition thing. Okay, the only difference is, under perfect competition, what matters is kind of the lowest marginal cost. Whereas under Corno competition, what matters is average marginal cost. But in fact, as n increased, some of these Corno firms would probably leave the market as well. Okay, so some of you managed to do this. Did anyone else manage to do the second problem? Other than no. Okay, well I'll spare you.
Can we go through it anyway?
Yeah, I'll go through it. I'll spare making him go through it. That's what I meant. Okay, so why don't one of you have a go at doing it?
I can try.
Yeah, good. Thank you. I think I volunteers. That's good. Okay, so the trick is exactly the same as in the other case. Okay, so you start by writing down profits. And again, the typo's still there, so again, this cost function should be exactly the same as that one up there. Okay, so just keep all that up.
So should I change it to I?
Yeah, CI, and make it a little Q as well. Okay. Not quite sure what I was doing. Just a second. Yeah, so she's the price was k times q to the minus beta. We've got price times quantity. Okay, so it's k times q to the minus beta times q. So q to the minus beta times q is just what you've written down there, q to the 1 minus beta. Yeah, so that's right.
And then differentiate.
Yeah, exactly.
Is it for small q or?
Yeah, for little q.
I don't need a little q here, right?
So, so it's maybe. Okay, so what? Let me get another pen so I don't distract you. So one way you can do this is to expand big Q as a sum of the little q. Okay. The other thing you can do is to use the chain rule. Okay. So d of, let's say, some function of big Q. Okay. D of f of big Q, d little q. Okay. Using the chain rule, that's d of function of big Q dq times d of big Q d little q. Okay, so can we do, maybe this is easier. Okay, so what's d big Q d little q? Given what the definition of big Q is.
The rest of
It's 1, isn't it?
Yeah, exactly, it's just one. Okay, so this term is just one. Okay, so you're exactly right with what you were doing before.
Should I write down
So what you're doing is your function here is q to the 1 minus beta.
Yeah.
Okay, so you're using this formula. So
I don't need to write anything.
no, carry on. Oh well, you still got
Q.
yeah. So you're doing the derivative of q to 1 minus beta in terms of big Q. Okay, so d q to the 1 minus beta d big Q. Okay.
Oh yeah.
Yeah. And then q to the, so it's q to 1 minus beta, so overall is 1 minus beta out the front, which you got, and then you got nx, so it's nx to the n minus 1, so this becomes minus beta.
Oh yeah, that's true.
Yeah. Yeah, exactly.
And then I change this to the average.
Yeah, so you add across all of the firms. Exactly.
And then just rearrange it.
Okay, so she's done 2 steps in one. Has something gone wrong?
No, that's fine. Yeah.
I think it's minus on the second line, isn't it? C10 minus.
Oh yeah, you're right.
So I'm not sure if that.
Yeah. So
It was right.
Yeah,
Okay. So we've done 2 steps in one. So she's added across all of the firms. Okay, and I see where we went wrong. I knew it didn't look right. Okay, so the very first line was something a bit off. Sorry, I should have stopped you earlier.
Not the marginal cost? Oh, no, sorry. No.
No, so profits are a function of total
Yeah.
cost, that's right. What about...
yeah, that's what I was thinking the whole time. I didn't know if I was to point it out or not. Because if you multiply that, you don't get that. If you multiply q with the whole function, and you get to that bit. Can I just do it on the board?
Well, yeah, show me what you mean.
So,
Just
because like. Q, right? So it's like.
So that what you've written down there is equal to that. So that's not the problem.
Is it not?
No. So big Q times Q to the minus beta is just Q to the 1 minus beta. You know, think of this as, you know, if you have Q times Q squared,
Yeah.
okay, that's Q cubed.
Mhm.
So you can just add the powers up. So here you've got Q to the power of 1 times Q to the power of minus beta. So that's Q to the 1 minus beta.
Oh,
Okay, so that wasn't the mistake. Sorry, don't worry. It's good to clear these things out.
Is it that big Q should be a little q?
Yeah, exactly. So for profits, what matters is, you know, the price is the market price, but what matters for profits is my quantity. Not, you know, it doesn't matter how many units you sell. I only get revenue from each unit that I sell, right? Okay, so because that's a little qi, things are a little bit different further down. Okay, so sorry, I'm gonna. You're on the right lines. I should have just stopped you earlier. So sorry. Okay, so
Tom,
yeah.
as the question is to show under monopoly that is the same, should we not go through it as if it's a monopoly problem, which would mean that Qi is equal to big Q?
I don't know. No, that's you know, I clearly did mean to under monopoly. And it just shows that absolutely no one did these problems in previous years. Otherwise, these silly mistakes would have been fixed.
I was going to say, because even under monopoly, it still works. You still end up following that method. You still end up with C1 over 1 minus beta,
Yeah.
which is exactly the same because the average marginal cost in a monopoly is the marginal cost of the monopolist, and beta over 1 is beta.
Yeah. Okay. Yeah. It made sense, but it wasn't what I meant.
Okay.
Okay. I must have been having a bad day when I got to writing these problems down. Sorry about that. Okay, so yeah, here's our profit function. Okay, and just as before, we're going to differentiate it. Okay, to derivative of profits for firm I with respect to quantity produced by firm I. This thing we're going to get by the product rule, okay, so we get the derivative of price with respect to little q, okay, which we can just use this formula for. So that's just exactly the same as derivative of price with respect to big Q. Okay. So just as before, we get, you know, nx to the n minus 1, so minus beta comes down. So we get minus beta k q to minus beta minus 1 times little q. Okay, so we've got derivative of that times that, and now we do that times derivative of that. Okay, so plus p of q, which is kq to minus beta, times little q. Times derivative of little q, which is just 1. Okay. Minus the derivative of total costs, which is just ci of 1. Okay. So the next step, you know, at the moment this looks messy, you don't know what to do with it. Just always follow the same rule, always add across the n firms, okay? So we're adding across the n firms. So what are we going to get here when we add across n firms? What's this expression going to become? Go on.
Change it to add them together for the small q.
Yeah. So the small q's are all going to get added together, and they're going to become big Q, right?
Yeah, and change the c to average c.
Yeah, if we're also dividing. Okay, so let's do it in two steps, just so we're clear. Okay, so we're just adding first. So this is minus beta k q to minus beta minus 1 times the sum of all these qi's, okay, which is just big Q. Okay, this doesn't have an I in front, so we're just going to get n copies of this term. Okay, q to minus beta. And then when we sum across all of the marginal costs, we get n times average marginal cost. So, can we simplify this expression? How about, do you want to have a go at this? Simplifying that times that?
Okay, I've got something about it.
Just minus beta without minus 1.
Yeah, exactly, sorry. Yeah.
How does that work?
So this is q to the power of 1.
Yeah.
So you get q times minus beta to the minus
Oh,
1 plus
okay.
1.
Yeah.
Okay, so the plus 1 cancels with minus 1, you just get q to minus beta. Okay. Okay, so the next trick we're going to use is to remember that the price is k times q to the minus beta. So when you're working with these isoelastic demands, you know, it's often helpful to substitute the price back in. Okay, so this is just minus beta times the price plus n times the price minus n times C1 bar. Happy? So all we've done is remember that k times q to the minus beta is p. Okay, so we're just replacing all by p. So now let's take all the p's over to the other side. How many p's do we have? Well, we've got minus beta here, we've got n there. Okay, so we've got beta minus n p on one side. And that's going to be equal to, done this silly way, so minus n C1 bar. Okay, so dividing through by that and flipping the signs as well, we're going to get price is n times C1 bar divided by n minus beta. Okay, and then to get to the formula we've got on the slide, this is a fraction. If you divide top and bottom of a fraction by the same amount, you still have the same fraction. Okay, so this is C1 bar divided by 1 minus beta over n. All we've done is divided the top and bottom of the fraction by n. And that's what's on the slide. Happy? Is everyone else happy? Reasonably? You sure? Okay, good. So, you know, just as before, as n goes to infinity, okay, n gets bigger, this bit gets smaller, so this comes to 1, okay, so as n goes to infinity, price goes to average marginal cost. So, you know, if everyone has the same marginal cost, then this is going to perfect competition. Yeah, and again, this looks like markup pricing, right? With monopoly, price was something times the monopolist's marginal cost. Now price is something times average marginal cost. Okay, and the more firms there are, the smaller the markup that each firm is going to choose. Okay, and we've done this already. What happens in each case as n goes to infinity. And when I say, is it efficient? And what I was talking about here was just the fact that this average marginal cost is not the same as, you know, marginal cost in a homogeneous industry. Okay, so that was those problems. We got time to do some in the book. Yes, about. So what did I set you? So did you get stuck on any of these exercises from the book?
The only question I had is, on one of them you have to do the sequential games, the Stackelberg ones that weren't in the lecture. Do we have to do them, or do we come on to the Stackelberg ones later?
Which question was it?
1 part C, C and D.
2.6.
I'm sorry, 6.8.
To be honest, we're not really going to look at Stackelberg competition. I presume you've seen some Stackelberg previously, haven't you? You know, so yeah, I'm unlikely to ask you about Stackelberg in the exam. I think you can conclude that pretty comfortably. So I'm going to keep the right exercise.
6.8, I think.
6.8. Okay. But I think I set those exercises because they had some other bits in that were useful, and I was hoping that the Stackelberg bit wouldn't throw you too much. Yeah, so part B was Corno. So A and B you could reasonably be asked in an exam. Don't worry about C and D. E was Bertrand again. So the answers to all of these are online. People have said in the past that the answers online don't have a lot of detail. So for ones you particularly want me to go through, I'm happy to. Was one of these hard? Which one did you find hardest? I'll go through that one.
The Stackelberg one I found hardest, but that's fine.
Sorry. So, well, let's just have a look at what kind of questions they were without actually doing them. Okay. So the first question was standard competition question with linear demand. Okay, and asymmetric marginal cost. So that's, you know, it's just a special case of what we've just done. The next one is also a special case of what we've just done. Okay, so we've got Corno competition, linear costs. But okay, it's not a special case quite, because total costs here aren't linear. Okay, so we looked at examples with linear total costs, whereas in this question 2, total costs aren't linear. But it's not going to change things too much. So we've got this total cost function. C is f plus c of cost function I is a function of i's quantity, f plus qi squared. Okay, and you're doing Corno with P is 1,000 minus big Q. Okay, So it's going to be pretty similar to what you've seen before. So you're going to get price times quantity, 1000 minus q times little q, minus total cost. So at the optimum, again, you use your product rule here, okay, so derivative of this, which is just minus 1, okay, because derivative of big Q with respect to little q is 1. So you get minus qi plus 1000 minus big Q times derivative of that, which is just 1, minus f minus derivative of this, which is 2qi. Okay, so all that's happened is that you've now got an extra q bit over here. But when you add across firms, it's going to be pretty similar to what you've seen before. So naught is minus big Q plus n times 1000 minus big Q minus n times f, okay, minus 2 times big Q. So, whereas before you just had Q's here and here, now you've got some extra Q's there. It's not fundamentally going to change how you solve the problem.
Sorry, what set was that again? What problem is that?
This is 6.82. And then I set 4A and 4C. So this is Bertrand. Yeah, so some asymmetric Bertrand competition. I should say I'm sorry for accidentally making you do that Stackelberg stuff, but it will be useful. We'll be doing lots of sequential games later in the course. They just won't be the Stackelberg game exactly. So the techniques you use to solve Stackelberg are very useful. So it's good that you remind yourself of those things.
I've got lecture, but but can you stay longer because I got tutorial between 3 to 4. Is that okay? You stay and a little bit longer after 4 because I can ask you some questions afterwards. I know your office hours.
Yeah, if you come by, I'm free.
Okay.